Okay, so kinetic energy we know is going to be dependent on speed. So the more speed there is, the more kinetic energy. But it's also dependent on mass, because if something was heavier and moving at the same speed, then it's going to actually, if it did something, you're going to be able to get more energy out of that. So it must have more kinetic energy. In other words, let's say a 5 miles an hour tennis ball, you can't get much energy out of that if it slammed into a wall or if it did whatever it did. Whereas a 5 miles an hour train would produce a lot more energy, right? So that's how we know that they're related. The half and the fact that it's v squared is it's something you're just going to have to remember, basically. So when it comes to the gravitational energy, that's a little bit easier to remember. Whoops. Because basically, if we imagine a ball lifted up in the air, then we know it's got gravitational energy because it's up in the air, right? Now, if the ball was heavier, then it would have more gravitational energy, because in the same way, it has the potential to produce more energy. Let's say if it hit the ground or whatever it might do, if it was heavier. Likewise, if it was raised higher, it would also have the potential to produce more energy. And if it was on a different planet, had a stronger gravity, then it would also have the potential to make more energy, because it would hit the ground faster if it had a stronger gravity. So these three can be kind of worked out, can be visualized. With this one, you just have to remember the half and the v squared, and then just you can try to understand that it's m and v. I'll briefly talk about elastic energy, which is half k e squared. The k is the spring constant. So if it's a really stiff spring, and it's like really hard to stretch, then we would say it has a high spring constant. And then the E stands for extension. So if that would be E, and the rest of it would be the original length. And the only reason I bring that one up right now is because you can see it looks very similar to the formula for kinetic energy. They give you one of them they might give you both of them. They give you one of them. I think they probably give you elastic energy, because I'm almost certain. I'll have to check it now, but I don't think they give you both, but I might be wrong. They might give you both, but I'm pretty sure they give you one of them. And then you could at least say, you could use that to go, oh, I know the other one's very similar to this, and so yeah. So